And we're back. These are molecular compounds. So a little bit of review from last time. We had ionic compounds. Ionic compounds are formed when electrons are transferred. They actually switch from a metal to a nonmetal. However, covalent bonds are formed when two atoms share a pair of electrons to complete their bond. They actually give the two electrons are going around both atoms at the same time. They stick together because both atoms need those electrons for the stability from the octet rule, okay, or the duet rule from hydrogen. Now, covalent bonds usually occur between nonmetals. Okay, so all the ones over to the right-hand side of the periodic table. There's no transfer of electrons, therefore no ions result. The metals don't give their electrons over to the nonmetals like it occurs in an ionic compound. They are shared between the nonmetals because both of them need to have all of the electrons involved. They don't have enough electrons to make everybody happy, so they have to share them. All right, now the characteristics of our covalent bonds. They are found in paper, plastics, and everything in all plant and animal cells and tissues. Everything that is organic has covalent bonds in it. Now, bonds are generally weaker than ionic bonds. They generally have lower melting and boiling points than ionic compounds, which should make sense to you. We breathe oxygen, we inhale carbon dioxide, although we don't want to. Most of what we inhale is nitrogen. Those are all nonmetals. Those are all covalent atoms that we're inhaling. And if it's a gas at room temperature, that means it's already gone through its melting and boiling points at much lower temperatures. Water, for example, is a liquid at room temperature. And so uh, it's got to have a lower melting and boiling point than something than say salt, which is a solid. So think about that. Think about gases and liquids and solids, and the gases and liquids that we deal with at room temperature have significantly lower melting and boiling points than ionic compounds. They are generally flexible bonds versus ionic, which are strong but brittle, and that's what makes ionic compounds. That's why you can shatter ionic compounds. Now, a group of atoms bound by covalent bonds is called a molecule. Okay, this is as opposed to the formula unit. Ionic compounds use a formula unit, but covalent bonds form molecules. Now, they may have as little as two atoms in them. For example, there are 7 diatomic. So what do you think diatomic means? Di means two. Di means two here. Diatomic would be two molecules. And so we have diatomic molecules of H2, N2, O2, F2, Cl2, Br2, and I2. So all of the halogens, hydrogen, nitrogen, oxygen. So all of those can only have two atoms. They'll actually form molecules with just two atoms. Or they can have millions upon millions of atoms, such as like DNA and proteins, which are huge molecules. Okay, when they make these, they make molecular compounds. Now, a molecular compound is composed of different elements that are nonmetals that are bound together with covalent bonding. Okay, and so the way we write these is using their molecular formula, and this is the true formula of the molecule. It is the chemical formula of the compound, and shows how many of each element is in the molecule, as opposed to, again, the formula unit, which is just the whole number ratio of the ions in an ionic compound. The molecular formula tells you what atoms are in each molecule of the compound. So, for example, in every water molecule, there is two hydrogens and one oxygen. In a single carbon dioxide molecule, there is one carbon and two oxygens. In an oxygen molecule, there are two oxygens. Remember, it's one of the magnificent seven up here. Ethanol, which yes, is the stuff that your that grandma and grandpa like to get a little overboard with. Okay, this is C2H5OH. This is the same alcohol that is in your alcoholic drinks. If it is some other kind of alcohol, it is poisonous, and you can get very sick and die from consuming it. Ethanol, however, is not. Glucose, you guys might remember this, C6H12O6, from the photosynthesis and respiration units back in biology. Sucrose, which is two glucoses minus a water. Glucose will undergo hydrolysis and it will lose a water. So if we take an H2 and an O out of that, so we double it first. So C12, H22O12, and we take a 2 and a 1 out of that, it would be C12, H22O11. Add it back in, you'll see what I'm talking about. Ammonia is NH3. That is your cleaning solution right there. And octane, which is your gas additive, is CH18. And that will do it for section 8.1. Your homework is up here, page 216, numbers 1 through 6. And we'll see you guys next time.